So, the brave ones left. I want to talk today to you about continuous delivery. My introductory question was already stolen, who is doing continuous delivery? But I guess since it was less than I thought, then I suppose it means you're at the right place. To start off with, I want to just say that while I talk, I might have the one or the other thing that is unclear, or you might have a question in between. Feel free to ask. But I will try to have time for questions at the end. So interrupt me, it's no problem, but there should be time at the end. Okay? Any questions? So, basically I just want to briefly start about myself, just a quick thing. I'm actually originally from Namibia, down in southern Africa. But work brought me here, but even before I came here, I really enjoy software development, anything that has to do with it. One of my favorite pastimes. And I started back in the days with a monochrome 8 megahertz machine that was fast for the time. And 10 megs of disk, wow. But anyway, then I worked my way through all sorts of programming languages. I dabbled a bit with BASIC. Effectively adding color to a game that I had when we got a color screen. But I think my real, what I would call not professional, but my real programming experience, or the real programming language I used was Turbo Pascal, which I actually used for quite some time during all the way through to Delphi, up to later versions of the tool. It was a really great language. And then ended up dabbling with all sorts of other languages, doing projects in a few. Doing obscure things at university like Prolog and weird things. So I've played around with a few things. These days I'm working a bit with Python and PHP. I'll get to what we do at the moment in a moment. But basically I think my next personal goal is to start using Go, the language that Google created. I don't know if you have any opinions about that. Generally, I enjoy a challenge. I really like banging my head against something until I get through the wall. Never give up, and really just try to improve things continuously. Experiment with new technologies, see where it takes me. Just try to become better in general. A bit of the background of our company. I won't talk much about it. I want to talk tech and stuff, but just a bit of background. We're a company called Vaimo. Not to be interpreted in any Finnish context, nothing to do with wife. This is about 70% of our company. We're about 160 worldwide. And here in Estonia, we are a team of 27. And we focus 100% on e-commerce. So selling things online. We don't ourselves sell things online. We provide services to our customers to sell things online. So we do the full service. We do from web design to software development to hosting, and recently also strategy, helping our customers sell better online. And we use Magento, 100% what we do. Magento is an open source e-commerce platform built in PHP using MySQL. And that might, to the one or the other, it might sound like a question mark PHP, but actually it's a fairly well-engineered piece of software. Has a bit of a hint of Java in it, like from the structure. So it's a fairly nice architecture actually. But really, what I want to talk to you about is continuous delivery. And just to start off with basically the why, and I'll quickly run out to get my remote. Start off with talking about why do we even care about continuous delivery. We have all sorts of tools that allow us to, we have tools that automate all sorts of processes. We have compilers, we have all sorts of things, but why are we actually interested in continuous delivery? And really what this comes down to, it has a little bit of a foundation in this whole agile mindset of trying to really deliver or structure your work into small iterations so that you can get feedback from it. And that allows you to be essentially agile by being able to, at every point where you get your feedback, by making decisions about your next move, instead of doing a 6 months, 2-year project, and really only at the end noticing whether you were right or wrong. Continuous delivery takes this a bit further, and it's really about iterating faster and getting that feedback faster. It's really trying to accelerate that part of getting feedback, which is not so much about pure speed. You're not necessarily going to do more work in less time, but it allows, because you have faster feedback, it allows you to experiment a lot more. It allows you to learn more about the software you're building. And there are even companies who are now claiming to take the next step of doing something called continuous experimentation, because the tooling and the mindset allows you to really throw random ideas into your production environments and experiment with them on a small scale and get feedback on them, and then see, should you go on with them, should you roll them out, should you just drop them, throw them away. Okay. The tooling around it and part of the mindset, the practices that you use, they make the whole release process much more reliable and much less stressful. And I'll talk later about what release actually means in the context of continuous delivery. Often also because you have these fast iterations and you're really just throwing things, almost like throwing things at the wall, seeing if it sticks, you end up having less meetings because you end up having tooling and a framework for really just testing something. Does it actually work? There's no point to have a meeting about should we do this and what's the budget going to be and are we going to get paid for this, etc. Just try it, do it, and get feedback. And this all can happen in it can happen in a day, it can happen in less time. And ultimately it's more fun, especially the experimentation part and especially part of the automation I'll talk about. It just gets a lot more fun when through the experimentation and the feedback you end up actually building software that matters, software that's valuable, and that just is a great feeling to know that 6 months, sort of what I deliver today is useful today, as opposed to 6 months or a year down the line, maybe half of the features that I've built are actually ever going to be used. Okay, a bit about the background. As I said, it comes a bit from the agile thinking, and if I take a little bit of a detour through history, I'm starting here a bit at where this whole Scrum and XP kind of came into existence. Around that, Scrum focuses a lot on the process, or still today focuses a lot on the process, what meetings and how you structure iterations, whereas XP ends up focusing a bit more on the developer practices, the type of your test-driven development, your code reviews, your pair programming, these type of things. And out of those developer practices came also tools like, or concepts such as continuous integration, which essentially means that you have multiple developers or even your own code in various variations, and you have an automated system that pulls these code changes together, or you push those merged changes together, and you have an automated system that ends up building a piece of ready running software out of it. This build process can have all sorts of tests, automated tests in them. It can pull pieces from all over the place and construct a final package that you ship off to production to deploy. And the nice thing about this continuous integration idea is that I don't know who's doing continuous integration. Okay, little less than half if I have to guess. What you end up having is you have these automation tools that really run the same thing over and over again every time you make a change, and the end result is generally referred to as red or green. And it's usually like a checkbox or check mark that's green. That means everything went fine, your test passed, all the pieces fit together, and everything seems to run. Whereas red is, well, something went wrong. Okay. Then we go on and we say that if we have a continuous integration environment where we're doing a lot of automated testing, let's say we have everything automated and we really trust this thing, then if it's green, why not actually just deploy it? It's working, why not deploy it? So there is this mindset that grew out of this of let's just take it all the way to production and at the end, when it's green, make that automation server automatically deploy that change. That, of course, sounds scary to many, but if you think about your own development work that you do daily, you end up committing a fair amount of small changes. And if every individual one of these small changes makes its way to production, then it's quite easy to reason about a small piece of code. So you can actually say, well, this is 2 lines of code, or I changed hello world to hello John. It's quite likely going to run, so just ship it off. Okay? If something does break after such an automated deployment, you can reason quite well about what broke it, because it's that small little commit that you made. Okay? So it allows fixing things quite nicely. And that all ends up going, taking it further. There's this whole concept of DevOps, which some of you might be familiar with, where it's then ultimately, I think continuous deployment is partly there. It's not only just about developers creating software that can be shipped, but it actually ends up being a whole mindset of how do we actually get it out into production? How do we actually ship our code? Because I don't know if anyone can agree here, shipping is often harder than it seems. Once you're done with the feature that is, how the Agile guys call it, potentially shippable, to actually put it out there, there might be, I don't know, database migrations you have to run. There might be all sorts of manual steps that you have to do that just makes this hard. And it often sounds so easy just to release it. Okay? So continuous delivery came actually, the concept was coined by a company called ThoughtWorks, who does software consulting. And they actually took this, the first principle of the Agile Manifesto, and they said, basically it says, our highest priority is to satisfy the customer through the early and continuous delivery of valuable software. And that's essentially where the name comes from, and what we're trying to do is we're just trying to be quite early, so frequent, and continuously deliver value. But what is continuous delivery? What do you need to do to actually say you're doing continuous delivery? Okay? And to sort of boil this all down, there are really just 2 things you need to do. I talked about testing, I talked about automation. All of that stuff is essentially just additional tooling in the whole picture, but there are 2 things you need to do, or need to focus on. The very first one is essentially you care about the feedback about your code, and essentially what you want to know is my code production ready? Okay? In fact, you take it a step further and you basically make sure that your code is always production ready. So any change that you always make in such a way that you can ship it to production. It doesn't matter if a feature as a feature as a whole is actually done or not, but you can still ship the code to production. So I'll talk about some strategies of how to do that, but that's basically what you try to do. That's part of the mindset of it all. The second part that you need to have in place is you need to be able to reliably deploy your software at any point in time into production. If you can do that, you're essentially doing continuous delivery. Okay? Neither of this means that you have to do it, but you have to have the ability at all times. Okay? And I think a lot of this, what I will continue talking about, I'll come back to these 2 principles to see how it all ties in there. A little bit more about the detail about the how. And there are a couple of points that I'm listed. This is not an exhaustive list. I can go on and on and on and talk about different things. But essentially the things that we felt are worth doing in continuous delivery are essentially automated deployment. That's one of the best ways of making that process reliable. And the second one is basically get your infrastructure identical everywhere, and the easiest there is to codify it, have tools for doing this. Do some kind of testing. You should be confident about what you deploy, that it actually is of any use or makes any sense. There are a couple of developer practices that help a lot in this, and ultimately, I'll talk a little bit more about this at the end, is it ends up ultimately being a mindset. I think all of the above essentially comes out of the mindset or the company culture when you start embracing this. All of the rest will automatically come about. So when we talk about automatic deployment, one of the key things that makes automatic deployment so valuable for reliability is that once it's automated, you might as well just do it everywhere. So you can do it's meant for production, but you can also do it to some kind of internal test server. And you can even potentially, depending on what kind of application you're working with, you can even do this on your local developer machine to some virtual machine or in some form of that. And that means during the life cycle of a project, essentially everything you do, you essentially always use the same deployment mechanism to deploy. So by the time, even if you don't actually ship stuff to production on a daily basis, by the time you actually ship stuff to production, you have tested that process 1,000 times over. So that gives you the confidence that this is going to work in production. Okay? But of course there are a couple of rules. One thing is that, as often said, build only once. So from your source code that you check in, you end up building one thing, which is generally called a build artifact, which you then deploy to some internal test server. You might deploy it to some server where your customers end up testing on, some user acceptance testing, and ultimately you deploy it to production. But the key thing is to continuously always deploy the same thing that the build server generated, because that allows you to, again, have the confidence that I've tested this thing, I put it somewhere else, it is the same thing, it has to work. Of course, only deploying green builds makes a lot of sense, but there's also a bit of a mindset thing here, because as soon as you start saying, this error is not so important, it's red, but let's ship it anyway, then the whole system starts falling apart. So forcing yourself to always deploy when it's green, or only when it's green, is fine. It's good. The concept of single path to production, I think I saw this in the notes from the previous speaker, that they essentially, one of their goals is to have a single command that gets their stuff deployed. I think he showed 3 or 4, but I guess it's a journey they're on. The point is you try to have a single way of getting to production, which even in the previous speaker's case was the case. So that there's no thing that you use an FTP client here to update some files and then you, I don't know, use a memory stick for this and you email this to an admin who places it there and then etc. And for dev, you do this by yourself with FTP, but for production, you use some other system to do it. Essentially, what you want is one single way, because that makes the process predictable. It doesn't necessarily make it more reliable necessarily, but it makes it more predictable. So if something goes wrong, you can exclude all those other ways of things. You know what's there is what was placed there by your automation. And then last thing, of course, deploy the same way everywhere, which I effectively mentioned a bit already. Use that same command to deploy to any place that you deploy to, even if it's testing, even if it's production, should be the same always. Infrastructure of code, I'm not sure how many people are using things like Puppet and Chef. 1, 2, 3 and a half. This is cool stuff. You should look into it. It takes a little bit of getting used to this. It's again a bit of a mindset thing, but it is really cool when you end up having code that defines what your servers are actually like. And much more than that, it becomes a way of, especially once you take that to development environments, even on local systems, you use the exact same code that configures a production server on your laptop that sets up your laptop, or a local virtual machine. You end up having this, it works on my machine, kind of just goes away, okay? Because your machine is essentially the same as the final server. So this is really cool stuff, and then this in itself you can do in a continuous delivery style. You can essentially have a shared repository that even your ops guys and your developers share, and the developers need certain things installed for their local dev machine, and when they eventually deploy that same code that configured the local dev machine will end up setting up the production machine. So it's basically quite high likelihood that it will work fine. Testing. Testing means a lot of different things. to different people, and it also has different value in certain different cases. And while basically you should have some form of testing, because you have, with continuous delivery, you have this way of just delivering or releasing code all the time, but something should still give you the confidence that what you're going to actually release makes any kind of sense, or that it actually works. Now, testing doesn't have to be automatic. It's a lot of talk these days about automatic testing. It doesn't have to be automatic, but of course, machines are so good at it. And we're software developers. We're good at writing software. So let's write software to automate things. But essentially, there can also be cases where you have a perfectly test-covered piece of software. You build, everything is green, you deploy it to production, and the customer says, nope, that's not what I wanted, right? And to have some kind of testing in there that somebody says this actually makes business sense is sometimes needed, and manual is often good enough for this kind of stuff. Okay? In general, there are two types of tests. There are the type of unit tests, even integration tests fall into that developers care about. Does my software do what I basically meant it to do? And do the pieces fit together? And then there are generally things that are more customer, from a customer perspective, your acceptance tests, which generally test the system as a whole. And it's really, does the software actually do what it needs to do to solve my business problem? Both of these can be automated. Very often acceptance tests are not automated, but there are good tools these days for doing that. Unit test tools, there's in Java world, there's your JUnit, there are some others, there's PHP units, which we have in PHP land, which we use a lot. On the system level testing, which is often used for your acceptance tests, there are tools like Selenium, which automate web browsers, and I am talking about web applications here, which automate web browsers to actually simulate end users, click through the application, and see does it still do what it was doing before, and does it do what I expect it to do. Okay, a bit about developer practices. More or less all of these come from the mindset of XP, or extreme programming, where there are certain things such as test-driven development, where developers tend to write tests first, then write the production code. This actually ends up being more of a design behavior than it is a testing thing. The tests are the side effects. But those are things that actually help raise confidence when you continuously send out software. And the other parts, of course, is again comes from XP, is refactoring, where you try to keep your code. I'm borrowing a phrase here, but you keep your code clean, basically. You continuously try to make your code as clean as possible, because what you really want to achieve is to be able to change fast. So it's very nice to have this great machinery that allows you to deliver software fast, but if you have to spend weeks to reorganize your software to make a small little adjustment, then you're not exactly fast. You're not getting the fast feedback. Okay? So keeping your code in general quite clean is a good behavior, and TDD actually helps with that. The last one that I want to talk about, which I think is a little bit in contrast to our previous speaker, is this mindset of committing to mainline. Committing to mainline essentially means that if you have branches in your source control, that you essentially always commit to, or very frequently merge to, the main branch, and that is the branch that goes out to production. So our previous speaker said every time they release, they cut a branch, and that becomes that point in history so that they can come back to this to make fixes to this thing that runs in production. In continuous delivery, you change your mindset a bit, or a fair bit, to say...
If you do like Windows clients or anything like that.
Sorry?
If you do client-based releases, then you don't do it.
You can do this to some extent. This, of course, works best on web applications, sort of software as a service style. But you essentially change your mindset to say that what is in production is always my latest code. And you have mechanisms to ensure that that latest code, which isn't quite done, doesn't really cause major problems. So this is sort of opposed to the concept of feature branches, which I don't know, is anyone using feature branches? Okay. So feature branches are a popular way of working because it allows you to really work without the ground changing under your feet. But what you essentially end up having is every time you try to merge a feature back into the main line, you end up having to spend some effort to merge it. And modern tools, of course, make this quite easy, Git and the likes. But sometimes it's not just a choice of like what line of source code do you want. It's a little bit of what was intended here, what was intended here, and trying to resolve this. And even if it goes fairly painlessly with source merging, it still ends up adding up that time. Over time, that time you spend merging adds up and slows you down. With release to mainline, the idea is even if you do work in a feature branch, which we actually do because we want to have a bit of code review in the process, you'd still merge at least once a day back into mainline. So this is sort of some guideline as to when you're doing continuous delivery, merging once per day is for example, a good idea. Yes?
And if you merge back to mainline, does it mean that you make once a day code review? If you want to have code review as part of the process, how can you merge that off into master?
We are at the moment in the way we are doing these code reviews, we're actually slightly slower than that because we actually make slightly bigger changes. So it might be a day or two sometimes, but essentially we have these one-liners, and it's just as our own internal process that we want at the moment. So we want the code review. So even one-liners get via code review and they get merged, and 10 minutes later they're out and deployed. Yes?
How can you, using such approach, allow, or how do you develop bigger features which take from 1 week and on?
Yes, I will get to that in the next slide. One strategy for allowing you to do that. Essentially, what you essentially do, I might as well switch to the next slide. What you essentially do is you say, all my code goes out to production, but I'm going to use a couple of mechanisms to ensure that the code that isn't done doesn't actually get to run. Okay? And there are various approaches of doing this, but the one that I want to talk about today, because this is what I will demo, is something called feature flags. And with feature flags, what you really do is you take a piece of code and you put a switch around it. And you keep the switch off. And that way you can ship as much as you want to production. All the code is turned off. It won't cause any harm. And I also showed just now why this is quite safe to do. Yes?
Visually turned off.
Depends. I will actually show you how it's visually. I will show an example where it's visually turned off but still active, and I'll show you a case where it's actually turned off. So the one interesting thing with feature flags is, of course, that the flag can be switched not just on and off, but you can choose who do you want to switch it on for. And that's part of the thing that makes it so cool and so powerful, and I showed that just now, is that, that's what enables this continuous experimentation, is you ship a feature out into production, and it's mostly done. You don't know if it's stable, good, you don't know the performance characteristics of it, no idea, and then you turn it on for just yourself. And then you're actually testing this piece of code in pretty much, it's not even close to the real environment, it is the real environment. You're testing your code with real environment, real data, real like load on the servers, etc. And you can see it actually fitting into the whole application. When you then are more or less satisfied, as developers tend to be at some point, I tested it, right? And then it still doesn't work. You can enable it for, say, the rest of your team, or even for a subgroup of your customer testing, yes?
What if your feature you're working on includes include some database changes. Let's say rename some column in your database. Then there is no straightforward way to allow part of your users to use one name for this column.
Yes. I will get to that after my demo. Essentially, this doesn't quite fit the picture, but I'll show you a couple of strategies for that. So what the benefits you end up having is your code is always integrated. Your changes are always just a small piece of code. You can reason about them. You understand what's going on. And your code is essentially by default turned off. You can turn it on. There are even our own internal module currently doesn't support this, but there are feature flag modules where you can say, I would like this feature on for 1% of my traffic. So if you have 1 million users, you have a fair amount of activity against that feature, but it doesn't take your business down with it if it has a problem. The one thing I'd like to just add is, while we think a lot about stories and concept of Scrum and so on, feature flags should, in my own recommendation and own experience, feature flags should always be second to slicing your stories better. So when you asked, for example, just now, what if a feature takes 3 weeks to build or 6 weeks to build? If your sprints are 2 weeks or 1 week, or so let's say 2 weeks, which is quite common, then always prefer to actually slice the story better, to be able to release that thing, to actually release it at the end of that sprint, rather than hide it all the time, because you're potentially losing meaningful feedback, and you're actually adding a bit of extra overhead into your development process just so that you can fix a process issue, right? So I think as a team, as a sort of Scrum team, it's still valuable to try to improve that slicing of stories, become a lot better at that before you just rely entirely on feature flags. But it's a nice tool. Okay. So the last thing is before my main demo is that it essentially amounts to a mindset. A lot of this, as I said, will come out when you have the mindset. And the important thing here is that once you start introducing things like feature flags, your release and your deploy are no longer have to be the same thing. So, and as it's basically you can see as your deploy as being a technical event, but your release is actually more of a business or marketing event. So you might be building this big launch of some brand new feature and the customer wants a brand new theme and everything, bells and whistles. But that might be coordinated with television ads, it might be coordinated with newsletters, etc. So you can't just release parts of this into production, into user-facing users, because there's a whole business strategy behind it. With continuous delivery, because of things like feature flags, you don't actually care too much from a deployment point of view. You just deploy the stuff out. You can actually start testing with beta testers, with selected users, either internally or externally. And then once you are actually confident about this feature, you can just flip it on.
This kind of rebranding or retheming website is actually an interesting example, because if you deploy the new theme behind a feature flag, there's always a chance that by accident somebody will enable it, or there's a defect and it will get enabled, so people will see the new view by accident.
Yeah, a slight practical problem. I would say it depends a bit on how important this is to you. You put mechanisms into place. You have an automated test for this, for example, that the feature flag is never enabled for anything, or you have code that guards against this, and you have a test that tests that guard. But essentially, one of the design principles behind many of these feature flag modules is that it's hard to turn things on. They are built that way that it's hard to turn things on, because you don't want to just turn it on too easily. So it is always off by default. As a developer, you know when you hide something behind a feature flag, you don't have to do anything, it will be off. You have that confidence. And even when you want to enable it, it takes a bit of effort to say everybody should get it. Okay? So you tend to, the tools are often designed that you generally enable it for a small subset first and then ramp it up. Okay. I talked about small units of deployment already. Again, feedback, you care about the feedback. That is almost essentially the most valuable thing here. Because you have this continuous delivery of stuff, even if it's not turned on, you can start generating feedback from it, and that's what you really want. I kind of intentionally skipped one thing that's often on the slides for continuous delivery, and that is measure, collect metrics, and then sort of this measure and improve. But I think I excluded it because it's a fairly standard operational thing when you run web applications. I think that's a talk on its own. What do you measure, how to measure well, how do you alert, etc. And it's also part of the agile mindset, is this inspect and adapt. Always try something, evaluate, and adapt. So I excluded that a bit, but essentially feedback is the mechanism that makes this possible, and that's what you care about. And of course you care about production. You care about what I write here on my laptop now is going to be out in production in 10 minutes, assuming your builds are fast enough. But that means what I'm building here, you constantly have this mindset of how will this actually perform in production. And not only do you leave it at your own machine, you then enable it on production for yourself or for a group of people, and you actually try to see how does it actually perform in production. Often when you have these longer deployment processes or you build something, it's potentially shippable, but it only gets shipped a few months down the line. You have it's a huge disconnect between what your code does on your little machine and what it will end up doing in production. And 2 months down the line, it's really hard to care about it anymore because it's so hard to really reason about it. Focus on learning, same thing, using the feedback. And partly there's also this sort of who will pay for this mindset. I think this comes a bit in examples like us where we're a bit more of the consultancy type company. That you do have, but I guess it's in any business, you do have to think a little bit about all this infrastructure that you might be building, all the process that you might be building. It still has to pay off, and you still have to, so you can't build this all in one day. It has to take time. You have to basically iterate that entire transformation step by step. And I would always say start with automating processes, start with cutting stories smaller, but essentially you have to also motivate that change. And I think many of the benefits of this, especially this release is no longer equal to deploy, end up being quite powerful motivators for doing continuous delivery. Okay. Part of this also with the feedback is, and this is what I think you referred to, is sometimes you can also actually, with the feature flag, you can actually choose to have a feature visually not present, but still actually present. Facebook actually did this. When they launched the chat system in the Facebook website 1 or 2 years back, they actually had the chat client running for I don't know how long, actually sending messages from your browser when you were logged in to test load on their backend to see that messages actually arrived at the right place. So they were actually, effectively you were chatting before you even knew that there was a chat feature in Facebook. Okay, this feature is this concept is called dark launching. So you're launching something without actually anybody seeing it, and but you start already measuring. You start pounding it. You start experimenting with it. Okay. And when all of these pieces sort of start fitting together, you end up with what you will very often read when you read about continuous delivery. You end up with something called a deployment pipeline. This is a very simplified version, but basically represents something where you sort of hack on your machine, you stuff it into version control. You may or may not do a code review. Essentially, once you start getting into this flow of the releasing, you start actually relying a bit less on code review. And we're actually internally starting to move a little bit more to pair programming, where you essentially code review on the fly. So that step is optional in a way. Then you end up you're doing continuous integration, running your basic unit tests. And then I kind of hide the step a little bit in between. Very often your automation will then end up deploying this whole thing that you've built to some test environment and start running smoke tests on it. So actually just, does it actually start up? Can I visit the front page, etc.? So yeah, we're using a little tool called Casper, which is a headless browser for some of those things. But ultimately, you have the deploy is live. And this is really, what is really so cool about this is that I've made this manual and automatic color difference, is that eventually you start getting into this, write some code, push to Bitbucket, or in our case, Bitbucket, GitHub, and it's in production. If something goes wrong, you will be alerted by email or, in our case, HipChat, but essentially, you often don't really have to care that much about anything in between. The stuff is shipped. And then you can always go to production and start switching things on and so on. So, a little bit of demo time. One question?
About Magento, which kind of artifact are you using with Jenkins? So you mentioned that you should build it only once, like which PHP,
yes.
With PHP application. What are you doing?
Yes. We're using a tool to just do the build. We're using a tool called Composer, which pulls in all the pieces. And ultimately, we end up with a file tree, which is a tar archive. So that's our build artifact with a couple of extra things to get a basic Magento up and running, which, of course, in normal production, we don't have. It's just the initial seed data and stuff that we have. But that's our artifact.
Another question?
Yes?
Assuming that you would work for a bank or for an air traffic control system or some automatic missile defense system, do you think it can be, this continuous deployment can be adapted somehow, and what would you change if you would work in such a...
I think there are different scenarios that work differently. You'll have to adapt the process slightly, but essentially I've seen the question answered before in terms of the security context. High security things with especially like PCI requirements when it comes to payments and stuff. And essentially there are certain regulations around how things has to be audited, how things has to be, who has access to what. Once you start automating your things, you often end up having this audit trail. You end up being able to lock away things, and you can always have a manual step in between that is some kind of a third-person review process, and then a button click that only this guy has access to, and then the process continues. So in the pipeline itself, you have a choice of which of these automatically go to the next stage or which don't. In terms of specific, like maybe air traffic is important, I guess, you would, I suppose, end up having, whether you do continuous delivery or not, you would have a fairly stringent testing regime that qualifies the piece of code for the production use. And how much of that you automate, I guess, is a little bit independent of continuous delivery. If you end up being able to automate all of it, the brilliance of it all is that once it is automated and the same process happens over and over again, you will essentially have the confidence in the tool to release things. But again, it depends like how much can you trust the testing mechanism. And if it's manual, I guess you have certain ways of defining a minimum level of quality, and if it's automatic, you have a way of defining that. Okay? I guess that might also be a little bit more important to not launch a wrong theme in an air traffic control feature. You don't want that when it's not done yet. Okay, so let me just merge my screens quickly. Where's my mouse? There it is. Okay, I want to show you this quickly in the context of Magento. And I simply used the standard Magento demo data and standard setup. So this is a straightforward, clean Magento installation with demo data. Nothing too funky about it. But let's go and look at the case I want to illustrate. essentially what we have a normal online shop, and they're selling glasses. Now, suppose I basically want to add, under each of these classes, I want to add a ratings mechanism. So I'm busy adding a ratings mechanism to my website where I want to show how many stars is this thing on average. And of course, I might have some other functions that collect that data, but for now I'm focusing only on this view. In this view, of course, you can show 100 items at a time or something like that. And if you have a lot of products, depending on how you end up implementing this, firstly, it might be something that you plan to do over a couple of weeks. Secondly, depending on how it's implemented, it might have performance implications. Maybe you're a front-end person who doesn't really know so much about the database, ends up doing for each of these products, go load all sorts of data, your classic N+1 query, where we end up pounding the database quite hard to collect that data to show it. So let's build this thing in a feature flag style. So we actually build a feature without showing it to the end user. Basically what I'll end up with is a couple of stars down below the product. So I'm using, I hope this is big enough for everyone. I'm using a really cool tool called PHP Storm. And essentially what I have here is a template in the templating language. It's basically PHP. And this is the page that renders things like the price and product name and things like that. And if I, for example, do an echo test here, then I would end up seeing it here. But of course, I don't want that because this is a live site, right? I'm skipping deployment here for demonstration purposes. But essentially, I would like to just show the mindset behind feature flags and ask basically anyone here. Would you deploy this to your production site that is generating thousands of dollars every second? Okay. So likely this is something you would not want to deploy, and I can show you what will happen, just so it's easier to see the effect later. Because this is now being rendered as it goes, it manages to get up to the point where it wants to display this, crashes, and the rest of the products and everything is kind of not showing. So we don't want that on our production site. So next question, would you deploy this? Who would be happy to deploy that?
This is what version control is for, isn't it?
What?
To not deliver not ready features.
What, and how do you do that with version control? In a separate branch?
Yeah, you encapsulate it into some feature branch and store it there until it's ready.
Yeah, but how do you then deliver this to production?
Merge to master.
So that means it is not ready for production.
Yes.
Yes, and one of the two things of continuous delivery, first one is your software should always be ready for production, always. So feature branch in that sense doesn't qualify because it is not ready for production. And in theory, at least, once you integrate, once you merge, you theoretically have to run all tests again, all manual tests, etc., to be 100% sure that everything still works.
Assuming that you put everything in an if-false
Yes?
statement, it's equal to a branch. So
Essentially, yes.
Yeah, it only makes sense to make continuous delivery if you actually have something not in it false branch.
Yes. Of course, in this case, it is still better than a branch because it is already integrated. There's no extra work needed to integrate this. It's done.
You don't see how it affects the production instance, or how it will affect the production instance once we change false to true.
Yes, but I'm planning to do something else instead. I essentially want to just point out that in this case, I am happy to release this to production because in this specific case, PHP is an interpreted language. So if it never actually gets to this line of code, it will not try to make sense of it. So it is perfectly fine for me to write anything here. Of course, it is not 100% true, because if I do this, for example, if I forget the semicolon, then it is actually a problem. This will crash production. Okay? But of course, tools like PHP Storm, it actually puts a little review icon in the top right corner that is currently red. That tells you it has found an error, and I think if I click on it, there's a bar on the right-hand side. I can see that there's a syntax problem. Of course, there are command line tools to do this. You can put this into your actual integration server. Please just run a syntax check on every file, and your actual build will fail if you have a syntax error. As long as PHP is syntactically correct, it is all fine.
Even better, do a pre-commit hook to Git.
Yeah, pre-commit hook, then you get the feedback earlier. Exactly. So I'm happy to commit this, and it should, of course, also run just fine, so I see all my products. But of course, files is not very useful. So instead what we have, and this is now a module that we have built internally, we have a module called FIMO feature flag, and I want to call it rating, for example.
Is this model available?
Sorry?
Is this model available somewhere?
Not currently. It is very Magento specific. We are intending to open source this one, but it is very Magento specific at this current point. So this, again, from a design point of view, is intentionally so that this is a static class, so you can just call it. PHP Storm, because it indexes all the classes, knows that this exists, so making typos is a bit harder because you code complete it. And in addition to that, if I were to misspell it, PHP Storm actually marks it in yellow, which means I don't know this. And you can actually then realize that I misspelled it, and if it's all white, it's fine. So there are tools that help you see that this is not a problem. Otherwise, you would have some tests in place that eventually should fail. So if I now just run this code, then of course I still see nothing, but it works. And now, of course, just for testing purposes, let me echo test instead. And refresh that. And once again, I don't see anything, okay, as expected. I then will go and make this feature available for switching. And currently, there are different ways of doing that. Currently, in this Magento module, I would add a little bit of XML that defines feature flags, adds the keyword or the code, and adds a user-readable description. Doing it in the user interface is not always the best way, because very often it's actually a problem that you don't really have history and who does what and are they allowed to do it or not. So feature flags are actually nicer to implement in a simple key value type of file that you commit, you have in the same source control. So because deployment is so easy, you can deploy in 5 minutes or 2 minutes, you can change a flag quite easily and just deploy it back out again. So now what I will do is log in and go to my feature flags. This is the admin system for Magento. Just need to click one button once. And now I have my rating flag here, which is currently disabled. And I will now enable it. And just for demonstration purposes, I will enable it for myself using my customer login system. I think this is a bit small, but essentially I'm enabling the flag. I could also do customer group restrictions, IP address restrictions, etc., but I'm going to use email address. So I'll save it. It's enabled now, but I haven't identified myself, so still not there. Let me quickly log in. I log in, and I see my test. Okay. What is also nice to see now is, let me copy that same URL over to a different browser and load the same page. And now you see there's no test. But on my account, there's a test. So on one is I'm logged in, on the other I'm not. So production doesn't see anything. It's only me. Now, of course, I can go and make this a little bit more interesting. And of course, I have the code already in place. And I can change this inside here to say, get the actual summary and get the HTML. This is just some code I found. and again I refresh, and now I have my stars there. Of course, I just got this from somebody else in the company. I don't know how well it performs. I don't know if there are edge cases where it's going to crash, but for now I can test it on production. Again, in Safari, others on the web don't actually see this. Okay? And the last thing that I wanted to show is that I can, of course, now also go and, if the feature is enabled, I can simply, and those that know web, this is not the most clever trick, but it's going to do the job. I can simply wrap this all into an element that is set to not display. So this could be a form of dark launching, so that I now, if I reload this, I don't actually see this. But if I inspect this, I should be able to see above the Add to Cart button, I see my display none, and I see my ratings in there. Okay, so this could actually trigger some JavaScript which hits a backend, so I can do performance testing or evaluate how do my thousands of users actually interact with this service. Okay, and let me just stick this back out. I think this is basically a very, very rough demo of what feature flags allow you to do, and to see the power that I can make a change for myself only, and no one else will ever hear about it. Okay? Yes?
So, this is the visual feature flag I was talking
Yes.
about. Now, let's assume I'm a bank, and we have some algorithms for calculating the payments for the mortgage.
Mhm.
Say, and in 1 month, there's going to be a feature launch that changes the way how it's calculated. So how would you implement feature flags in kind of a more data, closer to data layer, like model, or how would you do it there? Like, would you duplicate different code paths, or use the same code path and reach by parameters? What's your kind of take on that?
One of the things that I haven't specifically mentioned yet is that I'll answer your question directly in a way, is that feature flags have a bit of a maintenance burden also. You can imagine that over time you accumulate all these feature flags and you kind of need to keep cleaning up after yourself. So once a feature is actually launched and it has proven itself, you can drop it unless there's a business reason for keeping the switch, right? We have customers that have these extremely high peaks during the year where we actually keep certain features where we just disable them. They are useful during the year, but during that peak they are just generate so much additional load that they get enough from just their visitors alone that we don't need this extra feature. But part of this maintenance best practice of maintaining feature flags is you try to actually not litter your code with feature flags. Instead, you try to have multiple implementations of your stuff and have the smallest possible place where you switch, which is usually a user interface at the user interface. So you can actually choose whether you want to show this brand new feature or whether you want to hide it. But the actual code that implements the new feature is all live and all there. And that also allows you to run your tests against it. So you don't have to jump through hoops just to make your tests switch feature flags so you can test your stuff. So you tend to keep all your code live, but actually use visual entries to control this. Back to the bank example, I think what you really want to do is you want to end up developing or your confidence that the new way actually generates what you intended to do. So instead of just doing your straightforward test that you run in some kind of build step, I think what you would end up having there is you would again have both code paths would actually be, again, you try to have as little duplication as possible, but you have both code paths, both actually calculating the results. Okay, there might be performance considerations, but in general, you would have them both calculate that. And at the end, you would then either store one and the other one would end up running through some assertions which generate some problem reports that it's either working as you intended or not. So they don't actually just test during build with some kind of sample data, but you actually test with every single transaction. So in that sense, the feature flag, again, is most of the code is live. You essentially just, in this case, would decide which value do you actually store in your final transaction, for example. Does that make sense? Or is that impractical?
I would add the
I
angle.
wouldn't do it like that.
I would add the angle to that example that you probably have a lot of shared code between the two versions of the calculator. So maybe the first step is to change the design of the component. First deploy a change where you bring out the module that's a shared code, and then you switch that over with the feature flag and make sure it keeps working. And then as a second step, you deploy the real business logic update.
But actually, when you do some bigger feature sheets, a lot of database and data changes. So when you put those tags, it doesn't happen that it might affect real data. So it anyway can mess up the product. So if someone do some future, it changes data not only related to him, but maybe some other aspects relates to that. Because this database can't be future like.
Yeah. Part of this, as I said, is that continuous delivery is a lot about being able to do something, but it doesn't necessarily mean you have to do it. So being able to release something to production isn't necessarily the saying that you have to do it. So when it comes to, I mean, standard common sense for this kind of testing is test it on some kind of staging system first. This doesn't really fall away. The more you can automate of it, the easier it gets potentially, but often things are not all that easy to automate. You tend to test too little or something. So this exploratory type of testing is still needed. So for certain things, you still, as a person, still have to decide, is this safe for production? Even though all my systems tell me it's green, is it safe or not? And so a lot of shops actually do have that final step to production is a button. So everything else is automatic, but that last step to production is a button. And I think you don't get away from testing that. However you test it, but you will have to be safe. And I think the whole mindset of experimenting, you should know what the impact of your feature is. And the fact that you're thinking so much more about production, I think actually helps you think more about what will this actually do.
One other thing about features affecting database schema is that at the beginning, this is just my thought. I came up to this thought like 5 minutes ago. Is that at the beginning you duplicate the data and keep both values in the database. For example, like you decided to rename the column. At the beginning, you keep both columns, and once a feature gets completely delivered, you just run migrations to sync the data and wipe this redundant column for production.
So
Yes.
for security purposes, you delete the data ever.
Yes, you just disable it. Yeah.
Something happens in the back. So
Yes.
you should understand that nothing comes for free. So it's like you should, for some period, delivering big products have code duplication and data duplication, and besides that, if something is wrong with initial version, you should have fixes in 2 places, storing that, and you should keep in mind that it's because this is a feature being developed, you should remove this feature flag and maybe code someday. So
I think what you specifically mentioned, I think it ties in also with your example, is you don't get away from good development practices. So, for example, taking in your example, taking that you end up having duplicate code paths. That is generally something you try to avoid when you have your code.
Like
so
2 totally different algorithms, you cannot share this code base.
no, but that means there's no duplication. Basically, you have this concept.
Duplication from business process point
Yes.
of view. But one is calculated 2 plus 2, and another is multiplying.
Yes. So you have this one design principle which is called the open-close principle. It basically means that you take a piece of code, any code you write, you try to design it in such a way that it is always what they call open for extension, but closed for modification. So you basically write your code so it never gets changed internally, but you're able to extend it. And one of the classic examples is your polymorphism in inheriting or in object-oriented code, where you have a base class that does something, and or you have some interface that defines a couple of different classes, and they all have different implementations of the same thing. And you end up basically, when you do want to have two algorithms, you try to refactor your way to a place where you have shared base class, for example, and the two specific implementations in the detail class. So that means that you can essentially change which implementation you eventually want, and the rest of the system doesn't really care because it all conforms to the same interface. Now, again, there are certain things that work better in practice than others, but that's, for example, one approach that could work with the algorithm thing.
Which sometimes ends up with the code for a motorcycle and an airplane having the same code base because they both have an engine.
Mm-hmm.
But it requires quite a bit of sanity to know where to split them.
Yeah, it is, as I said, you don't get away from that. It's not like, if it was easier, I think we would all be out of a job and just automate the thing. So yeah.
You do practice this approach in your daily process, and maybe you can try for attention to some gotchas or things to be aware of, or to avoid, or some most common mistakes in this feature flag approach.
I think one of them is of course data, a database. We talked about this, but I think what you just mentioned, your approach, is what I talked about, the three-step changeover, where you make changes sort of incrementally, and because you can roll them out relatively quickly, it's often quite painless to do. Of course, sometimes just copying values over from one column to the other is not really something that you can do in production, but you might have a maintenance period for that. I think this was my slide that's supposed to answer that question a bit. Not 100% the same thing, but I think generally automation, I think, is one of the things. Invest time in that. Even if you basically take 10 things, automate each of them, and you still have to run all 10 things one after the other. Next step is to take a couple of those and automate them, etc., until you're down to a single command for things like deployment and so on. I think investing in actual automated testing, especially at the code level, is something extremely valuable. This is something we're finding on a daily basis, where it's like, we see this paying off for us. It is a bit hard. It requires a bit of a mindset change to think about testing, and once you start writing automated tests, it's a new thing you have to learn how to do it, what works, what doesn't, and but it's definitely well worth the investment. And I think the big thing is this mindset, thinking about production, thinking about how can I get feedback from the work that I'm doing. That's basically that. Okay, and a little bit in summary, this is, if you as a single developer, you can also benefit from it, even if the rest of the organization doesn't do this. As I said, write the tests, even get your own little continuous integration server up, something that sends you an email when something breaks. Get into this feedback mindset, get into that. Automate deployment, even if it is just for yourself, eventually you get it into production anyway, because it works. And yeah, that's basically that. Great.
So how many test environments you have? Do you have just development and live, and that's it?
No, we typically have 3. We typically have the environment that the developers play around with, and that's not the stuff on the local machine. So in that sense, we have 4. But then we have an environment that our customers end up testing the features that we want to deliver, or that they want to have delivered. So we actually test this before production with the flips all switched on, and then we still have our production environment.
Okay, if developers just commit the code and after a few minutes it's in live environment, as a system owner or this person who has this business based on this system, I would be really worried about that, because it's like really good way how to create every kind of features and security codes there, because if this code is just go live without even having any, okay, security review stuff, then how you can be sure that everything's okay?
Well, but this is essentially, as I said, this is a simplified model of a deployment pipeline. You can define what your deployment pipeline is, and wherever you have these special requirements, I mean, if you have a small 10-person team, everyone on the team trusts each other, they're all building to a common goal, a common problem. Likely you have a...
Trust, actually, it's security, nothing to do with trust.
Well,
Security
it depends.
trust.
Security is trust, exactly. Security is trust at the end of the day. And it depends on your processes in place, that how serious do you need to take it. I guess a bank needs it a little bit more than my toy project. And to have those processes in place that ensure where it is important for you that you have those reviews. And each of those steps can be a manual process. It's just that at every point, like maybe this Jenkins guy isn't actually an automatic server, it is just a stage where we expect somebody to review the code or do security testing, I don't know, pen test the thing, whatnot, and then eventually click a button, I approve, which in itself can be whatever, digital signatures or whatnot, to allow the automation to continue.
How do you, you mentioned that in test environment you got all the features turned on for testing. How do you ensure features not affecting each other in test environment, because this might happen like really easily, especially if they're like some siblings.
Do you mean test where you actually manually go and then see how it works, or do you mean an automatic test environment?
I mean some features might be dependent on each other, and some features might like exclude others, or just affect in a way. How do you ensure the behavior you're testing is clean and it's not going to change when you like turn off some other feature? For example, this is a problem we have. We currently thinking of how do we have a separate testing instance for testing a single feature or showing a single feature to a customer, and we have to use some like workarounds, hacks, and like deploy it temporarily some feature. And this is my question: how can you like be sure that features are not affecting each other?
I would say the general recommendation is to keep your feature dependencies quite low, to effectively have a fairly flat tree, if you want to call it that. But you are inevitably going to run into these cases. So in case of when you do have, as I said, your flat feature flag structure, sort of default answer is have that all enabled in testing and test the features all active. So that's your general test environment. But when you do have feature dependencies where you do need to test one feature without another, and there is a reason to actually expect that this can cause a problem, you will have to eventually have these variations in place and test them all in these combinations. Again, it depends, is it important for you or not? And of course, if you have this process automated, it shouldn't be too hard to just duplicate. Of course, it needs machines, but you duplicate your build process, and you can run them all parallel on different deploys of the same thing.
Normally, your test suite, normally these things produce so-called floating bugs, which like appear like in some circumstances, and of course, really often this kind of situations are not covered with tests. So this is my concern.
Okay, I think we need to cut it here. You can talk to me afterwards.
I would just like to get a simple clarification idea. So some of the
Is this for the group, or can we take it afterwards?
Yeah, maybe we can just
it's
continue
for the groups in question. Some of the products have user rights built in. So by implementing, for example, some modules using the rights system to be enabled to turn on or off certain features for certain users is actually the same way as you are using feature flags.
Mhm.
Am I right?
No, it's a different system. In my case, I use the login as the identifier. I can use that the module allows to use cookies or IP addresses or all sorts of different ways of enabling features. So it's a different system. So you can test your authentication system also using feature flags if needed. Okay, great.
Thanks a lot.
Thank you.
Here's the card for you.